All right, thanks for working with me here. Today we're going to work on the second note sheet out of the parallel and perpendicular chapter, and we're going to talk about the properties of parallel lines. Now, in the first lesson, we just talked about what it meant to be parallel, all that good stuff, what it meant to be perpendicular. Now we're actually going to put it to use. Now, I used this picture in the last note sheet. We numbered it from 1 to 8. And we just took every angle and we just gave it a number. And we said, hey, this is angle 1, 2, 3, 4, 5, 6, 7, 8. That way you could get an idea of what was going on with the different angle relationships. And so we're going to get back to that right here. And we are going to talk about the actual significance of the math behind it. Okay. And I think it's actually something that you can see when you look at it. And so I want to give it a shot here and see if you can figure out what's going on, because long story short, and we're going to get to this in a second, if you know one of these angle measures, you know them all, because you can work your way around the picture and get whatever number you need. These relationships are going to help you do that. So we're actually going to start with corresponding. Now, corresponding angles, in case you forgot, those are the ones that match up in the same corner. So upper left. That would be an example of that. Corresponding angles are always going to be the same measure if the two lines are parallel. Now, I gave the little parallel markings right there just to kind of demonstrate, well, if these are parallel, then all these things end up being true. So it turns out corresponding angles are congruent. Now there's a name for this. There is a reason why this is true. In the newest book that we have, it is called the Corresponding Angles Postulate. Okay. Now, that rule that says corresponding angles are congruent, it is called a postulate. Now, some of these rules are called postulates, some of them are called theorems. And quite frankly, that's not the battle I'm fighting in this particular chapter. As long as you can reference what is going on correctly, if you get that last word wrong, I'm not going to hold it against you, because I have textbooks that call that a theorem. And then the newest one calls it a postulate. So if math people can't even agree, then would it really be fair to hold it against the kids? I don't think so. So that's my take on it. And I'm just going to go with that. So essentially what that means is that no matter what angle 1 is, it will be congruent. Now that congruent symbol is just an equal sign with a little squiggly on top of it. It basically means, well, angles 1 and 5 have the same measure. They're obviously not the same. They're in different locations, but they have the same measurements. Okay, so angle 1 is congruent to angle 5. And you could do this all the way around. You could say angle 2 is congruent to angle 6. Angle 3 is congruent to angle 7. Angle 4 is congruent to angle 8. All of those things would be true. All right. Now, what about if we go on to the second one that we did the other day? We did same side interior. Now, same side interior would be like 3 and 5. Now, if you look, just by looking at this picture, angle 3 is pretty clearly obtuse, and angle 5 is pretty clearly acute. So it doesn't necessarily seem like you're going to be able to get much out of it, but you can, because it turns out same side interior angles are supplementary. Whatever the two are, they will add up to give you 180 degrees. Now, this one, in the most recent textbook, they call it a theorem. Now, when we go to the third one here, we're going to stay on the interior, and we're going to go to the alternate interior angles. Alternate interior angles, so that would be like 3 and 6, those are going to be congruent. And you can guess there's probably a theorem for this too. Now, remember, postulate, theorem. It's not worth freaking out about. If you get that last word wrong, it's okay. Just do the best you can. The way I would remember it, if it's me, for the sake of the most recent book that I have dealt with in geometry, is CAP. Cap. Everything else is a theorem. Now that leaves us with one more that you're going to find in the book, and that's going to be the alternate exterior. And so that would be like 1 and 8, because they are alternating sides and they are both on the exterior. And those would end up also being congruent. And we could kind of bounce around and we could do the whole thing to prove it, but ultimately you just need to know that that is the alternate exterior angles theorem. So let's review here. I'm going to pick out an example of each. We already did the first one here. If they are corresponding, they are congruent. So angle 1 is congruent to angle 5. Now, we have the triple S right here. Same side supplementary. So, if you're dealing with something like angle 3 and angle 5, you can't say they are congruent to each other, but you could say that the measure of angle 3 plus the measure of angle 5 would equal 180 degrees. So you can't say they're congruent, but you can at least go that far. Alternate interior, so that would be like 3 and 6. Now you could go back to the congruent part. You could say angle 3 is congruent to angle 6. And last but not least, alternate exterior, you could say angle 1 is congruent to angle 8. So a couple of shortcuts in helping you remember. Corresponding is the only one of the 4 that is listed as a postulate instead of a theorem. But if you get that wrong, I will not dock you points. If you can reference it correctly and you just get that last word wrong, I will not dock you. Because again, if math teachers can't agree, then why should we? It's okay. So we got this. We got 4 of them. So again, ways to remember. Same side supplementary, SSS. Alternate ones are congruent, whether they are alternate interior or they are alternate exterior. They are all good. Now let's actually put it to use real quick. Because again, if 2 parallel lines are cut by a transversal and I know one angle, it means I know them all. So example 1, the angles labeled X and Y are what type of angles? Well, if you look, they are both on the interior of the 2 lines, the 2 parallel lines, but they are on alternating sides. So they are alternate interior angles. Now, based on the theorem that was given to us, these 2 angles are going to be congruent. Solve for X and Y. Well, if they're going to be congruent, that means I know exactly what one will be if I know the other. X and Y will be the same. To figure it out, I have to look over here. Now, this angle and this angle right here are what are called a linear pair, because they are along one line. It is one line that's broken up into 2 angles, and we know that a straight line is 180 degrees. Therefore, I can just say 85 plus y equals 180. At that point, I can just subtract 85 from both sides and find out that y is 95. And if y is 95, we already talked about this. And this is actually example 3, so I'll move this in a second. X is also 95. Boom and boom. Okay. Let's go to these last examples, and in order to complete this, I want you to take that diagram just like you did before and just number it off super fast, and we will knock this thing out. If the measure of angle 1 is 58 degrees, list all of the other angle values. Well, essentially, we now know 4 of them, just with common sense, because now we can say angle 4 is 58, because that is a vertical angle to number 1. We can say angle 5 is 58, because that is corresponding to angle 1. And then we can also say angle 8 is 58, because it is a vertical angle to 5. Now, as far as all of the other ones are concerned, let me just steal a degree symbol here real quick. As far as all the other ones are concerned, all we have to do is figure out what would be supplementary to 58. Because as soon as we know what is supplementary to 58, we can then just use that over and over and over again. So we have it narrowed down that it's either going to be 58 or it's going to be whatever is supplementary to 58. So you can sort of just do that in your head maybe. Maybe you need to actually write it out. You're going to end up finding out that the leftover from 58 is 122 degrees. Fun fact, the hottest temperature ever recorded in the city of Phoenix, 122 degrees. Not that I'm from there or anything. All right, so 122, and 122, and 122, and 122. All right, next. If the measure of angle 3 is 3x plus 2 and angle 5 is 2x minus 17, solve for x. Remember, we kind of have it narrowed down to one of 2 possibilities. Either they are supplementary or they are congruent. So you look at this picture, you look at 3 and 5. 3 and 5 are same side, and remember our triple S. Same side interior angles are supplementary, which means they're going to add up to 180. So the part plus the part equals the whole thing, which we know is going to be 180. Now, I'm not going to spend time holding your hand on the algebra part. I'm just going to kind of run it down for you. I'm going to combine the like terms. I'm going to add 15 to both sides. And I'm going to solve for x and find out that x is 39 degrees. Now, it did not say to figure out what angles 3 and 5 were. Obviously, if you needed to, you could just take that 39, you could plug it in. This would end up being 119, and this would end up being 61. It did not ask that, so I'm not going to worry about it right now, but you would just, like I said, plug it in if you wanted more information. Last but not least, if 4 and 8 are given to you, solve for y. This would be the other setup. Now you've got 4 and 8, which are corresponding. And if they are corresponding, that means they will be congruent. So instead of doing the part plus the part equals the whole thing, you are just going to put them equal to each other. So in this case, again, I'm not going to hold your hand on it, but you're going to have to subtract 17 from both sides. Or I guess you could go the other way around. A lot of people like keeping their y's positive. And if you're going to do that, then subtract y from both sides. If you're going to subtract y from both sides, then that means you're going to have to add 15 to both sides. So that would actually be a time saver. That would save you a step if that's what you are interested in doing for yourself. Either way, what you're going to end up finding out is that y equals 32. That's a little bit sloppy, so let's write it separately here on the side and write it in the correct order here. We are going to say that y equals 32. And again, if you had to plug it back in to figure out each angle measure, you could. They're both going to come out to 49 degrees. All right, I hope this helps, and I'll see you next time.